Hi everybody, this is Shivakumar. Today we are going to discuss about gravitation. Right? So what is gravitation? The first question is what is gravitation? So any answers from anybody? Yes. Okay. So gravitation is nothing but it is a force. Okay? It is a force. It is a force. Right? So gravitation force. So from where we got this gravitation force? So it is a fundamental. It is a fundamental force. Fundamental force. Right? So we are having four fundamental forces, right? What are they? First one is gravitational force. Gravitational force. Second, weak nuclear force. Third one, electromagnetic force. Fourth one, strong nuclear force. Strong nuclear force. Right? So here we are having the first one, gravitational force, right? So what is this gravitational force? So the meaning of this gravitational force, the definition of the gravitational force is that it is the force of attraction between the two mass particles. So here what happens? Our topic is also called as gravitation. So for that reason we can say gravitational force. So first one we are talking about gravitational force, right? So gravitational force is that the force of attraction, between two mass particles is called gravitational force. Okay, so gravitational force means the force of attraction between the two mass particles is called the gravitational force, right? So from where we got this? So let us take Newton. So Newton is sitting beside a tree, apple tree. Okay, a apple fell down, right? So then what happened at the time? He saw the apple, right? He saw the apple and thought that why this apple is coming downwards only, it is falling downwards only, why not it moving upside? He raised the question, and by that some experiments he made a statement, that is that Newton's law of gravitation. Okay, Newton's law of gravitation. Right? Newton's law of gravitation. He made the statement that the force in the universe, every mass particle attracts towards the other mass. Right? So every two mass particles attracts in the universe. Okay? He made that, and he given the statement that so the gravitational force is proportional to the product of the two masses and inversely proportional to the square of the distance between their centers. Okay, so F is proportional to the two masses M1 and M2, and this Fg, here G we are using, that means gravitational force. So Fg is also equals to inversely proportional to the square of the distance between their centers. So we can say it is a central force. Gravitational force is also called as central force. And here we are having square law. So inverse square is there here. So it is also called as gravitational force. Is also called as inverse square law. Inverse square law. Right? Okay, so here we are having Fg, right? Fg, that is force of gravitational is is proportional to, let us say, proportional to the product of masses m1 and m2, and inversely proportional to the distance between their centers, right? So let us take the mass here, okay, another mass here, okay. So m1, m2. So the distance between these two is taken as r, okay. So here I am taking the point masses, right? Why we should have to take the point masses? To take that these masses at this point. So for that reason we need to take that the masses are point here, okay. So here what effect, Fg is proportional to the product of the mass and inversely proportional to the square of the distance between them. So here we are having the proportionality constant, right? So in order to remove this proportionality constant, first we need to take a constant that is called as universal law of gravity, universal gravitational constant. So Fg is equals to G m1 m2 by r square. So here this is the gravitational force formula. So here what happens, Fg is gravitational force, G is gravitational constant, and this G is also called as universal gravitational constant. Universal gravitational constant. M1, M2 are the masses, two masses, and r is the distance between their centers. Okay, so here we got this, right? So here we are taking the G. So what is this? What is G? So what is G? G is the universal gravitational constant. Universal gravitational constant. Gravitational constant. Okay, so here what happens, universal gravitational constant is G. So the value of this G is equals to 6.67 into 10 to the power minus 11 Newton. And here you see, here we want the value of this, right? This G. So here what happens, here we are having force unit is Newton, and now we would like to take this R from towards this side. Then what happens, Newton meter square, and this mass into mass square, so by kg square. So the value of universal gravitational constant is equals to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, and this value is also equals to 6.67 into 10 to the power minus 8 9 centimeter square per gram square. Okay, so this G value is also equals to 6.67 into 10 to the power minus 8 centimeter square per kg per gram square. Okay, so this is in MKS form and this is in CGS form, right? Okay, so here we got this. So here I would like to take two masses of mass M1 is equals to 1 kg and M2 is also equals to 1 kg, and the distance between their two masses will be equals to the 1 meter. Then what is the force? So here we like to take force. Force is equals to G M1 M2 by R square. So here we just need to substitute all the values here. So then what happens? This G M1 1 into 1 by, here we are having what radius, distance between them equals to 1 meter. So 1 meter square. So we are going to get the force is equals to G. So when there two unit particles, that is 1 kg and 1 kg, are separated by unit distance between them, then the force is equals to the gravitational constant, that is equals to the 6.67 into 10 to the power minus 11 Newton meter square per kg square. So here what happens? The force is equals to the gravitational constant, that is equals to 6.67 into 10 to the power minus 11 Newton meter square per kg square, right? So here we got this F is equals to G, right? And here we can also take that the dimensional formula. So what is the dimensional formula of G? What is the dimensional formula? dimensional formula. So here you see, here we are having this G, right? So let us take the G value. G is equals to F R square by F R square by mass 1, mass 2, right? So here we know that the dimensional formula of F is equals to M L T inverse, right? And for R square we need to take L square, and for the mass into mass square. So here we are having this mass 1 into mass 2 is equals to kg. That means M square, right? So here F is equals to ml t minus 2 and R square is what? L square by, here we are having M2. So the dimensional formula of the universal gravitational constant will be equals to M minus 1 L cube T minus 2. So this is the dimensional formula of universal gravitational constant. Okay, right. So this universal gravitational constant will be valid for everywhere in the universe. Whenever we go inside the earth and outside the earth, where we go, the universal gravitational constant will be the same. This value. So that what is the value? This, right? So the value of universal gravitational constant is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. So this value is valid in the universe. So we can also take this V value in the stars in solar system. Also we can take this one. Okay, right. Now we'll see vector form of Newton's law of gravitation. So in that, first we need to consider 2 point masses. Okay, so I would like to take 2 point masses. So this is x-axis, this is y-axis. Okay, so I would like to take a point mass m1 from here. So in the position vector of r1 and another mass m2, I would like to take here. The position vector is r2 here. Okay, so here we are using vectors. So we need to give the direction, right? So like this. So here this. So what is this? The distance here r21 and it also be r12. R21 and it also will be equals to r2. So the mod r21 is equals to mod r12. So the value of this will be equals to r21 vector is equals to minus of r12 vector. What is this? These are the directions. The values of the vectors here, the distance between the two masses here. Okay. So here I would like to take r1 vector. And here, from here to here, I would like to take. So here what happens? This will be equals to r21 is equals to r2 vector. So here what happens? r1 plus r21 is equals to r2. What is that? How do we got this? We know this, right? So if we take r1, this is r21 and this will be equals to r2. So vector addition. Right, vector addition will take like this. So this will be equals to r21 vector is equals to r2 minus r1. Right. So similarly, we can also take in the reverse process. So if we take r2 and this direction I would like to take here in this direction. So then that will be equals to plus r12. That will be equals to r1 vector. So then what happens? This r12 will be equals to r1 minus r2 vector, right? So this means the displacement of r2 with respect to r1, and this one will be equals to the displacement from mass 1, and this is the distance from R1 with respect to R2. Okay, so by Newton's laws, what are the Newton's laws? F is equals to G m1 m2 by R square. So here we are having that it is a vector quantity, right? So to represent the vector quantity, first we need to take this. So here what happens? This is m1, right? This is m2. These two are the point masses, right? So force on 1 due to 2. Okay, force on 1 due to 2. So then what happens? The direction will be towards the center. The direction will be towards the center. So then what happens? Force on 1 due to 2. Okay, so this will be equals to the direction will be like this. The direction will be equals to the R21. See here we are having 1 2. The force on 1 due to 2 is equals to G m1 m2 by R square, and here we are having the direction will be equals to the R21. Why? Because here the mass is always towards the center. The direction of the mass is towards the center of another mass, right? So here we know that R21 cap, that is the direction shows, right? So the value of this will be equals to R2 minus R1, right? By mod R2 minus R1. Okay, so the value of this will be also equals to the mod R2 minus R1. Okay, so this will be equals to this like this, right? So then what happens? R12 is equals to R1 minus R2 by R1 minus R2, right? So we got like this. So here what happens? F12 will be equals to, now we have to substitute this R21. R21 is what happens here? R2 minus R1. So then G m1 m2 by R2 minus R1 whole square, and in the case of R cap we need to substitute this value, right? So then what happens? This will be equals to R2 minus R1 by mod R2 minus R1, right? So this value will be equals to F12 vector force 1 2 will be equals to G m1 m2 by R2 minus R1 whole cube R2 minus R1 vectors. Okay, so F12 similarly here we got F12, right? Now we'll see F21 will be equals to G m1 m2 by mod R1 minus R2 whole cube R1 minus R2, right? So here what happening, this F21 is equals to minus of F12, where this F12 is equals to F21. The magnitude of this will be equals the magnitude of these forces are equal, but the directions are in opposite direction. So here what happens? If we are having mass, another mass, two masses are there, F1, M1, M2. So if we are considering this, that means the direction of this mass towards this direction. If we are considering about this, then the direction of this mass will be towards this direction. Okay, so these are the vector form of Newton's law of gravitation, right? Okay, right. So by this we got this. So here what happening? The vector form of Newton's law of gravitation is given thus. F12 is equals to minus of F21. So here we got this. F12 is equals to minus of F21, right? So here what happens? We can write that the gravitational force is attractive force. First one. Gravitational force. Gravitational force is attractive in nature. Attractive in nature. Okay, and these are central forces, right? And it is also called as inverse square law. Okay, gravitational vector, the gravitational law of gravitation is called inverse square law. So here what happens? Gravitational force is attractive in nature, and these are the central forces, and these are conservative forces. Conservative forces. Okay, so these are conservative forces, and this gravitational force is wide range. Okay, wide range. It is good for wide range distances also. Good for wide range distances also. Okay, and it is independent of medium. Independent of medium. So it is independent of the medium. So gravitational force is attractive in nature, and they are the central forces, and they are also called as conservative. They are gravitational force is also a conservative force, and these are good for very wide range distances, and gravitational force is independent of the medium. So independent of medium means what? So it is that independent of medium means, so whenever if you keep two masses in the liquid, so the gravitational force works. The gravitational force is same. If you take in some other fluid also, so the gravitational force is same. So it is independent of the medium, right? So here we have seen so many things. We have listened so many things. Gravity. So what is gravity? So gravity means what? The gravity is also a force. Gravity is a force. So here what happens? Force towards the gravity is a force of one of the mass is Earth. So the attraction is called gravity force. So here what happens? What is gravity force? Gravity is a force, and one of the mass is Earth. So the force of attraction of any object with the Earth is called gravity force. So I can write this in. I can rewrite this. Gravity force is the force of attraction of any mass particle with Earth is called gravity force, right? So here what happens? Gravity. What is gravity? Gravity is a force. The force of attraction of any mass particle with Earth. Here we need to take Earth is called gravity force. Okay.